becomes very unclear the lines between you actually playing a character that really, doesn't take his own statements seriously, or actually being seriously, but just obviously stupid.
It depends on what
Playing
I'm
a bar
talking about.
armbar, you're about to get Pete Shade up in here.
Well, no. It depends on what I'm talking about. Sometimes, because it's obvious when
of
I'm.
course, he's an actor. As an actor, he's always been an actor, Jeremy.
Okay.
Of course, but you know this as well as I do. But Lewis Carroll also knows this too, and he was writing.
Okay. Anyway, yeah. I mean, it depends. Like, when I'm memeing, you can tell I'm memeing, right? Like, I'm just trolling, whatever. But I wasn't trolling then. I was being serious.
Even right now, I can't really tell anymore, man. The lines are so blurred.
Oh, whatever,
regarding
man.
your character. Yeah, maybe it's what you want. At the end of the day.
Okay, man.
Who knows?
Let me see, guys. Shading.
So how about that accelerating particle? We get anywhere, guys? Did you team up? Did you huddle? Did you figure out the accelerating particle mystery, paradox? Call it what you wish.
What's the thing? What do we got going on here?
Well, we got their gravity, right? Holding the Atmos down.
Okay.
And then we got some particles escaping into space.
Okay.
Now.
Yep. They say we lose like 100
there.
metric tons a day or something.
Yeah.
What's up?
Yeah. We're losing all kinds, right, in space.
Okay.
Yep.
Now, how do them particles that are being pulled back, not flying out into outer space as we're hurling through the universe at 1.5 million miles an hour, how do those particles, which are kept in by gravity, how do they reach escape velocity, which is 25,000 miles an hour?
Yeah, probably if I don't.
Well,
me
don't they
personally,
blame it on solar winds, or the molecule gets heated up by the sun or something?
Yeah, they say all kinds. Yeah, but I mean, nothing that makes sense or anything.
I mean, if the atmosphere is so that the atmosphere is getting super excited on the daylight side.
Okay, go on.
I mean, well, that would have to translate, right? You got one molecule bumping into another molecule, and there's friction or whatever, drag, whatever you call it, the thing that makes the atmosphere spin with the Earth in the first place. You got that going on. So if you got one molecule going 25K, or a whole bunch of molecules up there getting heated up, wouldn't that increase the pressure?
Maybe. Yeah, I guess it would. I don't know though.
Well, we don't observe pressure. Do we observe a pressure increase when daylight happens, or?
Or how about at night on the other side of the mythical sphere? What happens then? Less pressure?
This must decrease as it cools down. No.
A lot of problems.
Did you guys? I don't know if you guys thought this through. There's a lot of issues with the globe thing going on here.
Seems like a lot of hasty thought, not a lot of logical thought put into it.
Well, they pieced it together throughout the years, so I mean.
Wait, so what is the argument?
Hold
on. Wait, what is the argument you're making, Jeremy? That's not so logical. Whatever. I'm confused. What did you just say?
Just now with the atmosphere?
Yeah. What's so logical or not logical? I'm confused.
I don't know if I said anything about logic.
Maybe it was SE. But someone was like, "Oh, it's not logical" or whatever. You guys literally just said this.
All right, I'll tell you. You want some logic? Okay. You have, like I said, you have your sphere, right? Surrounded by gas, hurling through space. next to a vacuum. Now, the excuse why this is not hurling off and killing us all is because gravity pulls the atmos to the Earth, right? You're familiar with that, Arma?
Yep.
Okay. Now, at the same time that this is happening, we have some of the atmos escaping into the atmosphere, right?
Wait, wait, the what?
Sorry, did I say sorry? You have some of the atmos escaping into space,
Yes.
into your model, correct?
Something like that. Yep.
Not something like that exactly.
Okay.
Exactly like that.
When I say something like that, I'm essentially agreeing. It's just that I don't know for sure though, because there's just yeah.
So something means okay for sure, but you don't know. Okay.
Okay, well, the
So
globe
now,
claims that you lose 100 metric tons a day or something. So
yeah. So how does that
you're
now?
just believing
In
all
order,
kinds of new stuff today, aren't you, Armbar?
Who said I believed that? That's why I literally said something like that. I don't know. Who said I was believing what he said? I'm not that I don't believe it. I'm just saying, like, how did you even come to
Yeah,
that
but you didn't
conclusion?
know. If you go, yeah, but if you go look it up and they say that happens, then what? Now you believe it, right?
Depends. I mean, how legit it sounds or whatever, I guess, or how convinced I am.
All science is saying this.
All right. Well, there you go.
Me and
Then.
Nancy didn't make that up.
Okay. So if that is correct, then okay. Moving on.
okay. So now you found out all these things. Okay, great. I mean, I wish we didn't have to teach you your model every time we have a discussion, but okay, it happens.
I mean, okay. I mean, I know that obviously, air particles, whatever the fuck, the atmosphere is escaping. I mean, I get that because there was a whole argument like a while back, like years ago, about like, oh, is Earth an open system or closed system? It's just I haven't personally studied this, so when I say, so I'm not confident in like saying like that's why I said something like that, sure, or whatever. Like don't like try to read between my the lines, whatever. I'm just unsure because I haven't studied it. That's it. You guys are like
fair enough.
over, yeah.
Do you know? Fair enough, Arma. You can't know everything, right? Now, do
Yeah.
you know what escape velocity is in your model?
Pretty much it's like the speed that you have to like hit in order to literally escape like the pull of like the body or whatever it is. Like you just have to
Okay,
hit
do
that.
you know the number of that speed?
For Earth, it's like, isn't it like 20? It's like it's in the 20,000. I think maybe 25,000 or something like that.
That's right, correct. So now, now we know now when a rocket reaches that speed, right? We know how the rocket does it, right? It has
Well, it's a fuel.
thrusters, it uses gas, right? That's how
Yeah.
they tell us, right?
Mhm.
That's the mechanism by which the rocket escapes the Earth, right?
Yes.
Okay, now, how does a gas particle do that? What mechanism does a gas particle reach escape velocity?
I could not tell you personally, but I mean, I've heard some arguments where it's like, oh, like the heat or whatever can, get it to, move around faster because that's how gases work or whatever. Like they're just bouncing around really fucking fast. So it's not far fetched to assume that if you get it hot enough, yeah, it could just go, escape velocity. So I don't know personally how it gets to that, but that's,
Okay, so
But
at noon, if that's what's going on, at about noon, we should have the highest pressure underneath. If you're at right underneath the sun, you should have the highest pressure at that point, right?
I guess. I mean, where exactly are we talking about though? Like this, like the edge of the atmosphere or something, or like? Because like I'm
I
pretty
don't know.
sure.
Does it not translate all the way down? How long does it take for this translation to happen of heating up and then the pressure heating up, the pressure raising the whole way below?
Well, I don't know if it's like good enough at like ground level, whatever. Because like at ground level, I don't think it's moving fast enough. But I know higher up, not only are you because you're higher up, you have to do a lot less work to escape Earth's pull, whatever. But I know like in term with the model, it's like the temperature kind of goes up. I mean, it goes up and down, whatever. But like
It's noon. Okay.
okay, but where exactly in the
It's
atmosphere?
noon.
Where in the
The
atmosphere are we
sun's
talking
been
about?
heating up the atmosphere. I don't know. You won't let me. You're not gonna let me, bro. You need to relax.
No, you're lagging, dude. You're
It's
kind of
noon. The atmosphere has been heating up above you all day.
okay. Hello. I mean, he's lagging, right? I'm not the only one. You know, like he's not like.
Lagging's not even there.
But yeah, I mean, I don't know too much on this, so I mean, I'm probably am gonna fuck up on this, but like, I don't know. I just know that it's on, you know, at like ground level. I'm pretty sure there's no particle that's gonna be escaping, you know, the Earth. What's
All right, cool.
Zanick might know though.
Cool, Zanick's there. Zanick, who told you that when an object drops, there's no force on it?
Einstein
Zanick, you
said
there?
that. Einstein said that.
What?
Okay, so Einstein said there's no force.
It's
Okay,
completely
and that is the
inertial,
way
there's no
physical
gravity.
reality
Well,
works, right?
pardon me?
And that is the way physical reality works, right? The way Einstein said it?
Yes, that explains the paradox very accurately.
How about Newton?
Okay, that is the way Einstein... Hold on, man. I know, we're going to get there, bro. We're going to get there. So that's the way Einstein works. When an object is in free fall, there's no force on it. Okay, got it. Einstein said that. That's your paradigm, right?
Correct.
Okay, so in Newtonian mechanics, you definitely need a force to have something accelerate, right?
Correct.
A real force.
Yes.
And there is no force. And there's no force there.
There's no force acting on
When
objects that are inertial.
things are free falling on Earth. When things are falling on Earth, there's no force, right? When things are free falling on Earth, there's no force there.
Because Newton said specifically that he thought it would be absurd to think there'd be some type of magical interaction between two bodies with nothing in between them.
Okay, we're not talking about that. I'm talking about Newton's laws of motion.
Right.
Newton said that for something to accelerate, you need a force. And when something's free falling, there's no force, right?
Correct.
And that's going 9.8 meters per second squared.
It appears to be accelerating with respect to the ground, yes.
So something's dropping at 9.8 meters per second squared. It's accelerating, and there's no force.
Correct.
And so Newtonian mechanics. So Newtonian mechanics does not work on Earth because there's no force there. And Newtonian mechanics, it says you definitely need a force.
They can be used and be very productive with their usage on Earth. Because just because we don't know or can accept there's no forces acting on these objects, if they are accelerating and we say that there is a force behind them, something magical with respect to the ground, then we will have action and reaction based on this acceleration.
Dude, I don't know what you just said. Newton said we needed a force to accelerate something. Einstein saying we don't need a force to accelerate something. You said Einstein is the way how physical reality works. That means Newtonian's second law does not work on Earth. Newton's second law of motion does not work on Earth. That's what you're telling me.
Of course it works.
No, it doesn't, because there's a scenario where we have no force and something's accelerating. That's not what the second law says.
We have something accelerating with respect to the ground, but the reason that we see the acceleration is not because the object has forces acting on it. It's because the ground is accelerating up to it. And that acceleration of the ground isn't accelerating with respect to a distance over time. It's a respectful change of direction with respect to the change of direction.
So in reality, in physical reality, the ground is raising up to meet the person.
The ground is accelerating upward, yes. Not raising
That's
up.
That's physical reality. That's what happens in physical reality. The ground raises up to meet the person.
You keep on conflating raising up with a change of direction. They're both accelerations, are they not?
You said it accelerates up.
If I don't change...
To meet the object. The object doesn't fall, the ground accelerates up, right?
Correct. But acceleration doesn't have to be a change of position with respect to a distance. It could be a change of direction.
Yeah, but it is a change in position. It is a change in position, though, because we have the position, and then you said it goes up from there. So we know the position change.
Right. The position change is caused by the actual direction an object is traveling through a geodesic. That geodesic is a straight line path. But with respect to the ground and you watching it from the ground, it looks like it's going straight. But actuality, it's actually has a curved path based on the warping of space-time. This changes the path direction of the geodesic. It can be circular, like an orbit is circular, and is actually a straight line path.
All right, cool. So here on Earth, there's no force when things fall, when things accelerate down. Newton said you need a force. Which one's right? They can't both be right.
They both can be right. Newtonian mechanics works on Earth. You can push with 1 Newton of force on a 1 kilogram mass and see it accelerate 1 meter per second squared. We know this to be true. It always is true. It never is seen.
You just said there's no force, Zanick.
No, I said
Hold on. These concepts are antithetical to each other. In one case, there is no force. In another case, there is a force. They can't both be true
they can be.
at the same time.
They
That's
can be.
a law of non-contradiction. There's got to be some logical fallacy happening
Well,
here.
you're completely tossing out the fact that the geodesic path can be a curved path. If it's a curved path, it looks like it's going straight, and it's running into something. There's nothing happening to that object. Like I said, it's accelerating, but it has no forces acting on it. Nothing. It is completely inertial. There's nothing acting on it. There are no forces, any size, mass, any density, no matter what you have, water, liquids, gases, they all are doing the exact same thing. They are not having any forces acting on them. However, with respect to the ground, it will impact those objects. It will, and the only thing that will stop them will be the ground. But how could the ground be stopping them if there's no force acting on something that is accelerating?
What the hell are you talking about, man?
Because they're not
Jesus
accelerating.
God
The
almighty,
ground
Lord.
accelerating upward.
Zanick,
Who was that?
This
making
is
this?
freaking beyond belief, man.
Zanick, just
Essie,
stop, bro.
Did you ever take a physics class?
I know.
Essie, you're being
Just stop,
completely
bro.
obnoxious.
Zanick, just stop, dude.
Zanick,
Stop.
my
Don't
brain is
respond to that.
hurting
Hold
me.
on.
It should hurt.
Hold on. Listen.
You're cooking at the cobwebs.
In one case, Zanick, relax, focus, bro, focus. In one case, there's a force. In another case, there's not a force. One of these is how physical reality works. There can't both be a force and not be a force at the same time. Those are opposing positions.
You ever hear of dialetheism, Zanick?
That's what it is. Tell him, Etsy.
This is the classical case of dialetheism,
No, it's
believing in two truths at the same time. Man.
denialism. It's called denialism. We've witnessed no force.
You got some opposing.
Denialism. You're denying the fact that we see objects, SC. Wait, let me
You're
finish the
denying
sentence,
reality, bro.
Ever since SC started blabbing away like he was out of control, Tourette's syndrome, and then you jumped in, I can't even get a word out. Come on. So we have an object, we see it to accelerate, yet we can also observe while we're watching it and analyze it that it has no forces acting on it. We know this because we can see objects in motion that have forces on them, like a rocket or a car, or you bench pressing, or you're doing some squats. We know these things can move with forces. These things are accelerating with no forces, none. Yet when they impact, there's a crash, there's distortion, there's energy release in the form of heat and noise. So how did that happen? It happened because the object is being stopped by the Earth, which is getting in its way on its geodesic path.
Okay, dude. If you have something hold on, Zanick. If you have something accelerating without a force, that throws Newton's second law of motion out the door. It's out the window. Newton's second law clearly states you need a force, and you guys don't have one.
Okay, so have you heard of centrifugal force before? Is centrifugal force a force?
Yeah, I heard of centrifugal force.
Okay.
Yeah, I heard of it. What about it?
Well, if you have something that's traveling in your car and you slam on the brakes, the object will continue in motion, following Newtonian's ideas. continue motion until acted upon by another force or action. So what happens is it's totally happy until the windshield comes into view, and suddenly there's an impact. Now that object had no forces acted. What happened was the object was in motion, freely floating and inertial, and then the car stopped, and now the object ran into the windshield. There's no forces on that object that ran into the windshield. Now hold on. Let me finish. The
This is a
windshield
huge red herring. Oh, no, we're not holding on. We're not
It's
talking
not a
about
red herring. We're talking about pseudo.
We're talking about
We're talking about pseudo forces. Talking
No,
about
we're
pseudo
talking
forces,
about
fictitious forces.
we're talking about gravity. We're talking about go to some other book.
Dialetheism is not a system of formal logic. Instead, it is a thesis about a truth that influences the contradiction of formal logic, often based on pre-existing systems. Introducing dialetheism has various consequences depending on the theory into which it is introduced. A common mistake resulting from it is that every statement becomes a theorem if a contradiction is true. So, like, everything that you're saying is its own theorem. If you're being dialetheism, trivializing such systems with dialetheism is an axiom. Other logical systems, however, do not explode in this manner when contradictions are introduced. Such contradiction-tolerant systems are known as paraconsistent logics. Dialetheists who do not want to allow that every statement is true are free to favor these over traditional explosive logics.
Well done. Exactly that. In other words, when you explode your logic, when your logic explodes, poof, anything is possible. Yes, you can believe in two truths at the same time. Yep.
Well, it's only relatively speaking now.
Yeah.
Depends on the reference frame.
That's reference frame dependent, correct.
Which is the definition of a pseudo force. Fictitious force, Lambert force, yes. That's the definition. A force without a source.
Have you heard of pseudo logic, Zanick?
No, this is not pseudologic. Not pseudoscience or pseudologic. This is a pseudo force. Fictitious force, which means all it means is the force is real, but it is without a source and it is reference frame dependent.
What is a force?
He said a force without a source. Please
What
elaborate.
is a force? Yeah, what's a force? Is a force a thing in itself, or is it just an action done, Zanick? Everything's a force, huh? Force here, force there, everywhere, force.
Supposed force making a non-force produce an effect that's like a force when you think of it like a force, but it's not a real force that we can measure like a force.
But like a Newtonian force is just
a force.
a Newtonian force is just like push or pull force.
The force without a force, Zanick. The happy force, Zanick 2023.
I mean, he's got a contradictory statement going here. I don't know if anyone else caught it. You can't have a force. It's one or the other. These are contradictory statements.
Yeah, they like to. The only thing they do is contradictory statements when they get to a cornered point, so that we like system malfunction. You know what I mean? Like we glitch out because they're really trying to get away with two contradictory statements at the same time.
Well, they just told us for 5 years that Newtonian mechanics was fine on the local scale here.
And I've been telling them for years that these are two contradictory things. One is mass attracting mass. The other one is the fabric of the bending of space-time. Like, ridiculous. They don't coexist. We've been telling them this for years. One is instantaneous. The other one is relative. The other one says that when the sun breaks away from the earth, we feel it right away. The other one says it takes 8 minutes. I've been telling them that for I don't know how long. It finally dawned on them, it seems. Wow.
All right, so you're not grasping the whole idea of the pseudo force. You're not grasping the idea of reference frame. I mean, I don't know what to do when you can't use the basic fundamental building blocks of knowledge for in physics. We're kind of at a standstill or a standoff. Think again about watching the Coriolis, for example. A ball on the merry-go-round, you see it curve. Now, it can't curve due to Newtonian laws. You can't have something with no forces acting on it make a curved path. But we see it make a curved path because it's being viewed out from the non-inertial reference frame, the spinning reference frame. So that's
we're not doing Coriolis. No, we're on
I'm not trying to do.
No.
Hey, I'm not trying to do.
But Essie,
Coriolis.
hold on, Essie. He's just giving an example, Essie. All right, like let him. Come on.
So
Okay,
in that
but
situation,
trying
we
to
have
redirect.
it's not breaking the laws of non-contradiction. We're saying that from a reference frame, it's breaking these laws of Newton. These Newton's laws are fixed, and even on that merry-go-round, you can extrapolate and do transforms and have Newton's laws work perfectly well. But we see something that shouldn't happen strictly based on Newtonian mechanics. Curved path of something you throw because it's reference frame dependent. No different than centrifugal force, no different than something falling off of a building, looking like it's accelerating, but the ground accelerating actually up to it. Thank you.
So tell us again how different these two things are, Newtonian and Einsteinian. Can you give us a brief explanation of how they are different, Zanick?
Einstein says strictly that when you apply force to something, it will have an acceleration. And it requires acceleration to accelerate.
And what does Newton say?
Requires a force to accelerate. That's what Newton says. That's what Newton says.
So
and Einstein says the opposite, no? No force, right?
No, Einstein still says that forces will cause an acceleration. There's no question there. There can be proper forces. All of Einsteinian real general relativity and special relativity do not address Newtonian laws specifically. They bridge the gap because of reference frame, because of general relativity and special relativity, talking about the bending warping of space-time and time dilation, etc. So what we see happening in the bending warping of space-time is these geodesic paths are curved, and it'll get in the way of things that are following straight line geodesic paths, which are actually curved with respect to that object.
So not a force. It's like a trampoline bend that you fall into it, right? So not a force.
Like a Coriolis force. Like something that looks like a force, but it's not a force.
Exactly, not a force.
So I'm going to take a bite of this apple, but it's going to taste like a carrot, but I'll still just call it an apple. Is that what we're doing?
No, I had a good analogy. That's a bad analogy, but go ahead. At least you're trying. The analogy is it looks like it's a force because it's a free-falling object, and when it impacts the Earth for no reason other than it getting in its way, that's called a pseudo-force. And that
so not a force.
Not pseudo-force does not mean not a force. It means it's a reference frame dependent force. Like a centrifugal force is a reference frame dependent force. Coriolis is a reference frame dependent force.
So is it
why you can't get any of these simple these now are becoming very simple. I was still talking. You know what I mean? These are very simple concepts, and there's numerous concepts I'm bringing up, and you can't grasp a single one without joking and mocking and just just belling all the information that's being provided to you.
Dude, you're asking us to say that an apple that tastes like a carrot is still an apple.
I'm still looking up centrifugal or centrifugal. That's what you like to say.
Either way.
What is centrifugal? Is that what is
centrifugal or centrifugal or centrifugal? Either way, you're correct. That is a pseudo force.
Centrifugal is not an accepted.
Of course it is. Centrifugal force is a. Of course it is.
No, you guys say it, but it's not really in any definitions of anything. Is it something you guys just want to talk about in engineering department?
It's the same spelling. It's just the way you're pronouncing it. It's very it's applicable.
You're centrifugal.
Centrifugal force or centripetal force.
Whoa, that's a different word.
It's centrifugal.
For the love of God, can we guys please fucking move on?
Centrifugal or centrifugal. Either way works. Same spelling, same
Wait,
word.
you even confused the two up just there. But
No,
like,
centripetal is a different force.
Yeah, here's the problem:
This
is
is the
it's actually
stupidest bit right now.
centrifugal, and Zanick's getting confused with auto mechanics and saying centrifugal, because centrifugal is actually what one of the components does in an automobile. It's a centrifugal clutch, but you're getting confused, and it's actually centrifugal and centripetal. You're welcome.
okay, thank you for
Centripetal is
helping
not
me out there.
central. It's not centrifugal or centrifugal. They're both the same word, centrifugal and they hear me saying it. Centrifugal, and centrifugal are the same word. Same.
What does this
spelling,
have to do with
meaning.
flat Earth?
Well, these are pseudo forces that we all know about. That is no different than what you see in form of Coriolis force, which is a pseudo force, or an object dropping, falling. Gravity. It's also a force like centrifugal force. So whoever that was Dicel, he's
Nothing
wrong.
to do with
In
flat Earth.
auto mechanics, we have a centrifugal clutch.
It has
based
nothing
on
to do with
forces.
flat Earth, dude.
Yeah,
Okay, sure.
it's fun, though.
It just has to do with his terminologies, and I like to just stay on board with that. Sorry
Okay, so
about if I was
centrifugal force would be the
distracting
force
into some.
outward. Centrifugal force, either way, is the force outward of a spinning, like a ball on a string. The object wants to go straight. Why? Because it's being forced to change directions. It wasn't being forced to change direction. There wouldn't be a centrifugal force. And the centripetal force is what's keeping it along that radius, it's keeping it turning. So that the tightness of that string is, you could say that could be the centripetal force.
I think they're trying to
And
do
how is
Gravity is like the
Right.
centripetal force.
Oh, okay, that's okay. I thought
Okay,
you.
so centrifugal force is the outside, is the force acting on the outside of a rotating object, right?
Going outward.
I said that, right?
Yeah, right.
Okay, and then centripetal is the axis of rotation around a center.
Right, the force keeping it going inward, the force inward. The direction, the arrow would be going toward the radius, toward the axis of rotation, and the centrifugal would be
if you say
the
like
outward.
there's a
Hear what I
reference
said?
position. We're talking about the same spinning disk. We're talking about the inside or the outside of it.
Forces are vectors, so the force of this vector would be going inward to the axis of rotation. That'd be a centripetal. The outward is centrifugal or
Centrifugal, as you like to say. Okay, thank you very much.
Centrifugal or
Okay,
centrifugal, yes.
I just wanted clarity on that. Thank you.
You want to know an easy way to remember which one is which?
No, I don't, and I didn't need it. I just wanted to call him on that. He's using a fictitious word. That's all.
So real fast, let me just not to whatever, but like, okay, I'm starting to see why like earlier Jeremy and whatever were like kind of like upset with me with what I was doing, whatever. Obviously, I was talking about a different thing. I'm seeing now what this is sort of turned into, like, or what they were actually talking about. Okay. So I guess gravity or whatever. The claim is that, like, I guess the Earth is accelerating towards, the things on it or whatever, which is interesting. But yeah, okay, I see now why. Yeah, that was very like
You remember
frustrating
the
earlier.
accelerating particle?
Yeah, what are you talking about? What are you saying right now?
Because earlier I had a whole thing where I was like trying to just explain how the Earth doesn't need to expand or whatever to accelerate towards Bob and Alice, whatever, right? But
wow.
I was talking about like a totally different thing than this, whatever. Like I realized they were talking about this now, so now I understand why they were so frustrated.
So can we come to the conclusion that gravity is not a force? Can we agree?
Who are you talking to?
No, fucking anybody. But you're a glober, so it'd be nice if you
It's a
answered.
pseudo force.
So it's not a force.
No, it is a force with
So,
reference frame dependent
it's either a
and
pseudo
without
force
origin.
or a force or nothing.
Listen.
It's
Pseudo
a
force does
pretend
not mean.
force.
It's a pretend
Pseudo
force.
force-
Yeah, that's what that is.
Can I finish?
Sure.
You could call it whatever you want. We'll let you call it whatever you want.
It is a force.
Yeah.
It is a type of force that is called a
Really
pseudo
wants to
force.
call it.
Still a type
Yes,
of
wants to
force.
call it.
Pseudo means not.
And this force is reference frame dependent and without origin. Those are the
Pseudo
two
means not.
constituents of
Okay,
that particular
hold
type
on.
of force.
hold on. So, okay, semantics or whatever, right? Whether we're going to argue that or not, right? It doesn't matter if it's like, even if it's not like a force, whatever. It's
or not. Yes.
Well, because we're talking about semantics and the dialetheism put together. When you take them both together, then you've got this wonderful concoction where, like, we can have trade-offs of words, we can have fake words that don't exist, we can have words that we both didn't understand because and then we can believe in two different parallel logics, and then we can explain the complexity of both and how that they don't fit, and that there's all these contradictions, and then we can argue about that. Or less complexity.
So then
would be better.
So then, are you guys arguing then that, like, what, centrifugal forces isn't really a force either? Because we still get something. We still get like an effect, like, things still move, in this, when you have centrifugal forces and whatnot.
I'm just trying to get you to answer honestly. Is it a force or not?
So is centrifugal a force or not?
No, gravity. Come on, you can do this. Please be honest.
Dude, in gravity, you have an acceleration with no force. Hold on, armbar. In gravity, your model, the way you think the world of physical reality works, there is an object accelerating with no force on it. No force. Newton said you need a force to accelerate an object. They don't mesh.
Hold on.
More semantical arguments. Now, you say that gravity is not a force. It's not even a pseudo force. It causes a pseudo force. That might be even the more accurate way, but that's still a semantic argument. If you talk to physicists about it, whether it is a force or causes a force, it's irrelevant to the discussion.
So not a yes or no question answer. Gosh, they are really bad at these.
The way physical reality works is irrelevant to physics, you're saying?
No, the definition of gravity is an effect. This law of gravity,
of what?
The cause of gravity, the fact that gravity is not a force, because you can't attach a value to it. It's dependent upon the mass. So it's not a force in itself. It causes a force. This gravity, whether it be Newtonian or Einsteinian, causes a force. It causes in Einsteinian by the bending warping of space-time. In Newtonian, it's caused by an attraction of masses proportional to the distance to and the size of the masses.
All right. So in what country or culture is that a yes or a no?
There's no yes or no. I just got to explain to you why it's not a yes or no question. Is gravity a force? If you want to go strictly in definitions, no. It causes a force.
Thank you.
Not a force in itself, because it's dependent upon the mass and the distance to them. Is the distance to an object a force? No. Is mass a force? No. Is gravity
explosive
a force?
Logic?
No. No, I'm just telling you
explosive
how
logic?
it works.
It's good. I finally got it.
Is Dancing Queen a song by ABBA?
Have you ever taken physics? I don't think you have. Yeah, I know you haven't actually, but so it's not a
You're going off all the information that you've given so far, partner. We're arguing information you've brought to the table. That's all we're doing.
I've given you all accurate information that no one in the field would disagree with.
So, but you can't be yes or no to it's a force. That's so weird. So you said, hold on. You did. You said no, it's not a force, and then you said but a bunch of other nonsense. But you did say it's not a force, given the base definition of force. Correct.
It's not a force. Yeah, by the base definition of force, it's not a force. If you talk to physicists about that, and I've done this because I got pushed like we did here about 5 minutes ago. Can I finish a sentence? Yeah, I'll let you. Let me finish. Can you try to bite your tongue for a second? So I did this about 5 years ago because of QE, and I went to the physics forum, and this when he saw my interactions with them, and I said, hey, could you, I'm having this discussion. Is it a force? Can I say it causes a force? What would be the best way to describe gravity? Just what do you guys, you freaking brainiacs are thinking? And then I got this huge response, 5 paragraphs of how it's, how it doesn't matter. Does it cause a force? It is a force. It's semantics. Here's why. And he gave me a big story about it. So I didn't really get the answer I wanted to, but I kind of figured I might get an answer like that. And that's what I came back with. That's from physicists. So it's not a straightforward question.
I got it. It's a not force.
It's a pseudo force.
No, a not force.
Or causes a pseudo force. It's a not force. Not even a force. It's not a force. It's an effect.
Yeah, it's a not force.
It's an effect. It's an attraction in Newtonian.
It's like an unforced.
and it's a bending, and it's an apparent attraction or an apparent force caused by the bending warping of space time.
I like pretend force. It's
Like, think of a force, right? Not that. That's what it is.
What do you think?
If you
Esty?
identify it as a force, you can be a force.
Esty, what here? Since you're thinking this thing
That's
through, and you're
pretty
actually,
cool.
thanks, Esty. Since you're thinking this through, and you're engaged at a pretty vested level here, tell me why some object can fall and you can measurably accelerate. See it.
All I
See
know
this
is,
path.
Zanick,
Hold on. Can you listen to my question
You
first
get
before
a
you try to answer?
force.
I don't want to
You
hear
get a
all you know.
force.
I don't want to know all you know. I want to know the answer to this question. And anybody in the field can answer this for me. If I see something falling and I'm measuring it to accelerate at 9.8 meters per second squared, when I drop it, measure it, but there's nothing acting on it. It's in free fall, and other objects near it are doing the exact same thing. What do you think could cause that?
I'll tell you. First of all, I'm sure all the boys listening right now, all the ballers are cringing. Because for years, you've been telling us you need a force, a force, a force, a force. Now, all of a sudden, Zanick woke up one day and decided there's no force all of a sudden. So, good on you, bro. That's the boys are going to be talking about this for days, I'm sure. Zanick.
I'm glad. And this came because of Witsit. We started talking about Einsteinian mechanics, and that became, oh boy, here we go. We can't even get through Newtonian, and here we go, and the major leap into Einsteinian mechanics and equations.
Look, I already have a disciple. Zanick,
So,
I have a disciple. Extremis is agreeing with a not force. So we have one already.
it's a force, it's a not force. Okay.
It's not force, yeah. I mean, come on. I mean, you guys are forcing us to ridicule this now.
Sensei says
It's gone
is
beyond
gravity a
logic.
pseudo force, not a force, or a force, actual force. Well, there's something in physics we call that proper force for actual forces, proper forces. Now, is pseudo force an actual force? It is an actual force, but it is reference frame dependent, and it has no origin. So it still is a force, but it has those requirements.
Imagine
A
saying that
force without origin.
to a
force
female
without
who
origin.
identifies as a female, but is not really a female. Like,
Yeah.
you know, I mean,
She's an orphan. We have no
this-
idea where she's from. There's
right?
no
Like,
origin.
you've got no origin. You just,
She's
you're
dropped
fake.
off on the firehouse doorstep.
I mean, that's what you're talking. You're talking, feelings here. Nothing of factual actuality. Just how
It's a
you
narrative.
feel is how it goes.
It's a narrative thesis. And explosive logics to follow. Yes.
What's a force, Zanick? Is it an actual thing, or is it just what something does?
It's something that imparts an acceleration on mass or matter.
Oh, perfect. What is that something?
Force.
Right. Can you describe that?
Something that imparts an acceleration in mass.
You keep invoking something like as if it's like mysteriously there but not there.
It is all mysterious.
Okay. All right. As long as we're on the same page.
It shouldn't be, right, Zanick?
Well, I can push my fan on your face and push on it, and it will accelerate. So
Well,
that's something is my hand pushing on your face.
It's like saying we have a car that with the engine that puts a force, but I never show you the engine, right? Or what is causing the force.
Whatever's exactly. That's a good analogy, actually. I don't know if you knew this, but that's a great analogy. It could be a motor. It could be little mice inside of there. It could be a electric motor. Doesn't really matter as long as we get a force that's being generated.
It doesn't matter.
And that force requires energy. That energy is be this power per unit time. A watt second. How many watt seconds?
It sounds like energy and force are the same thing to me.
They're not. God, energy is the rate of change of kinetic energy. I mean,
this is a new force. This is the Zakinian not force.
The rate of change of kinetic energy, the rate of change, how much power it have.
It'd be Zanickian, right? The Zanickian.
The Zanickian, yeah, that's better. Yeah, I like that. The Zanickian not force.
Dude, that's got a beautiful ring to it. Zanick, get to it. You can copyright sayings and slogans and shit, right? Oh, all of a sudden that's not worth responding to. Okay, well, when you guys can demonstrate that gravity is a force, you can then justify all the years of us being raised hearing in science and physics classes the force of gravity, right? How many times have we heard the force of gravity or the law of gravity growing up
The
in
law of
school?
gravity. What causes attraction in objects, and the size of the mass and the distance between the masses will determine that force.
So outside of very specific lab conditions that we have to take your word for the results
No,
of, and I know that was a
just
bad
drop something. Just drop something. Put something on a scale. There you
no,
go.
no, 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 that's not it. That's
That
not a
is it.
demonstration.
Because
No,
if I put
that's not a
if I put a
demonstration of
1
the why.
kilogram,
We need
if
cause
I
and
put a
effect.
one, if I put
Cause
a
and
1
effect.
kilogram, if I put a 1 kilogram mass on your scale, it's going to read 2.2 pounds.
We need cause and effect.
I have mass,
If we do that
and I
in
have a
water,
force.
Zanick,
If I put a larger weight on there, I will a larger mass on it. Like if I put 10 kilograms on there, I'll have 20 point whatever 22
We need the cause of the effect.
pounds. I'm telling you the cause and the effect.
Oh, what's the cause?
You're putting it on the scale.
Yeah, me putting it on there, right? So what's the cause of your
You like that? You guys always say
imaginary
that.
downward acceleration?
it's simple.
The cause is going to be the cause is bending. The cause is the bending
the
and warping of
scale has
space
a
time.
mechanism which when you put something on top of it, it pushes the sprints down and give you a reading.
Yeah, the bending and warping of space time is giving that mass. It's following a
That's where
geodesic.
you
It's being
go to
stopped
Magic
by the
Land.
scale or the Earth, and it's being stopped
No.
from moving, and that will cause a force in it, and that force will
Don't go
be
to Magic Land, Zanick.
it'll be
All is
10.8.
happening is that
It'll
object is
be
pressing on the
okay.
sprint.
So silent. You're proving to be unable to be having a normal conversation as an adult.
Well, when you go to Magic Town, it's hard to have a conversation, you know.
Well, when
No,
you
it's
go
only hard 'cause
to
you're-
when you go to Incredulity Town, it's hard to have a conversation.
Sure. I'm the one talking about magic, and I'm the incredible one.
When you go to Nuh-uh Land and ignore the fact that you step on a bathroom scale.
Of course, if you go to Magic Town, I'm just gonna say nuh-uh.
Yeah, you say nuh-uh because you
I
don't
don't need to
understand that
listen
this
to
is
you,
basic
right?
science. Of course not, because you have your head fully up inserted.
Mm-hmm.
Yo, I'm not saying he's got anything inserted necessarily, but it seems like perhaps his microphone is inserted too far into his throat. I'm not sure exactly who was talking. Is that Silent Zero?
Nah, I think we can move on though.
Okay. That's just too much. That's just too much.
No, I mean from gravity too. Because like the bottom line is you don't have Earth's curvature. You don't even need to get to gravity. You can't.
Explain to me why objects in a box. Explain to me why objects in a box.
Gravity is easily measured too. Step on a scale.
That's a demonstration of things happening. I want to know the cause and effect of why those things are happening.
To observe the effect. You observe the effect.
Let me finish. I want to understand the cause of all of the effects happening, not just go step on a scale. Oh, look, shit happens.
Yeah.
You need to explain why.
That's all you need. No, you don't. You can explain explain that the phenomena happens. We can observe the phenomena.
Take a look at a scale and shut your mouth, kid. That's what you said. Thanks. Appreciate that.
We can measure the force. We can measure the 9.81 meters per second per second. We can send, we can calculate the trajectories of rockets. We can calculate the trajectories of baseballs. All this stuff we can do using our understanding of gravity.
You said per second twice.
9.1 meters per second per second.
Like it's fun to say. I wish I had reasons to say that.
I'm sorry, I had a very anal physics professor. You can measure 9.1 meters per second with your cell phone.
Is no one talking? Check.
No,
So-
Jeremy.
You're all been quiet now. Have a nap time, Jeremy.
Yo, physics is about how physical reality works. All right. If one guy says you need a force to accelerate an object, and another guy says you don't need a force to accelerate an object, those are two very different things that are opposite of each other, and they both can't happen at the same time. One of them definitely is not a thing. So
I agree.
Newtonian either
No, go ahead.
either real quick, either Newtonian mechanics works on here on Earth, and Einstein's bullshit, or Einstein's the real thing. Wait, did I get that
No,
backwards?
you got the well. You're incorrect because Newton tells us what, and Einstein tells us why. You don't need to use Einsteinian gravity and Einsteinian physics unless you're going really fast, you're really small, you're in a really big gravity well. Other than that, Newtonian physics works quite well. Thank you very much.
No, it doesn't. It doesn't work well. It doesn't work at all because
It works
in
quite
one of
well.
them,
Thank you very much.
it doesn't work at all because in one of them you need a force to accelerate an object. In the other one you don't need a force to accelerate an object. So those
Actually,
are two
they work quite well.
two
They explain
totally
the same
different
thing
things.
differently. The tensor equations of Einstein break down or collapse, if you will, to Newtonian when you use.
Yeah, it doesn't matter though because in one of them
Actually, it does. They're both the same.
there's a
They're just two
force,
descriptions of the same thing happening.
and the other one there's. I'm not even talking about. Am I breaking up or are you just talking all over me?
You're breaking up.
And what we're not even talking about Newton's gravity. Okay, I'm not even talking about Newton's gravity. I'm talking about Einsteinian gravity working in conjunction with Newton's second law. It doesn't work.
Actually, it works quite well, but that's okay.
It doesn't work because what's Newton's second law of motion?
F equals ma.
F equals ma. So you need a force for an acceleration, right?
Correct.
Okay, and in Einsteinian gravity, there's no force and we have an acceleration, right?
Yeah, because space-time bends, which guess what, shows up as a force in our three-dimensional world. It's an emergent force.
No, save it with your emergent forces. There's no force.
It's an emergent force.
There's no force there.
The bending of space-time gives us.
There is no force.
The bending of space-time imparts the force that we perceive as gravity.
Yeah, but there's no actual physical force there. Newton says you need a physical force to accelerate an object.
We perceive it as a physical force because we're locked in three dimensions.
Yeah, but there's no force there.
We perceive it as a force because we're
You can't have Einstein and Newtonian mechanics both working simultaneously at the same time because one distinctly says, maybe I'm roboting. I might be roboting, so I'm going to try to not get mad, but I feel like that's not the problem.
Well, again, you're incorrect because Newtonian physics breaks down or collapses to Einsteinian, or the other way around. Einsteinian will collapse to Newtonian physics in non-accelerating, non-relativistic environments. All the tensor equations break down right into the same equations.
Okay, now let Jeremy respond.
Yeah, the math is irrelevant. We're talking about the way physical reality behaves. And in one of them, you have physical reality. And in one of them, you have physical reality behaving like you need a force to accelerate things. In another one, you don't need a force to accelerate things. They can't be both simultaneously happening at the same time.
Actually, it can because, once again, in three dimensions, the bending of space-time is perceived as the acceleration of gravity.
Okay, if you think you can have two opposing things happen at the same time, that's neat, but
no, you can. They're not opposing. One explains how, one explains why.
They are opposing.
No, not at all.
One has a force, one doesn't. There's two totally different things.
Again, if you'd listen to me one last time, I'll try to say the bending of space-time is perceived as the acceleration of gravity in 3 dimensions. Einstein's equations will collapse into Newton's equations in non-relativistic, non-accelerating fields.
It's not about the math. It's about what's happening in physical reality. And one of them says in physical reality there's a force to cause an acceleration. Another one in physical reality says there is no force. They can't both happen at the same time. We can keep doing this, going around in circles all night if you want.
But it is about the math, though. It's all about the math, and because math is the
No, it's not.
math is the language of physics. Math is
No, English.
No,
Language is the language of
math
physics.
is the language of physics. Newton invented calculus to explain his observations. If you can't do math,
His observation of objects moving in straight lines.
If you
mean his observations of objects moving in straight lines through free space?
If you don't understand,
bro, you took a pause. I thought you were done.
If you don't understand math, you probably shouldn't be talking about physics.
This isn't about the math of the physics. This is about the physical reality of the physics and what's actually happening in reality. And one of them, oh my God, bro, I'm not. I can't.
You're breaking on me. You're breaking on me. I'm sorry.
Yeah, I know.
Math is the language of physics. Newton invented calculus to explain his observations.
So you know he's breaking up a bit. Give him 2 seconds before you start talking. Be courteous.
Thank you.
Go ahead, Jeremy.
Yeah, it's absolutely not always about the math. Okay, there's descriptions on how things happening and what's going on in physical reality that's actually taking place. And in one of them they say there's a force there. Okay, and another one they say there is no force there. They can't. Despite what you think,
You're pretty bad there, Jeremy. You're breaking up, bro.
But things both can't. There can't be a force and not be a force at the same time. That's literally impossible.
You broke up, but we got the gist of it. I think you got the gist of it there, Shill.
Yeah, I got the gist of it. In the meantime, though, one explains what we would call normal space. The other one explains a warping and bending of space-time. These are two different explanations for the same phenomena. The fact that you don't understand or can't think in 4 dimensions, let alone 3 dimensions, is beyond that. I'm sorry.
All right, he's playing a cue to Captain Picard.
Too bad Jeremy's breaking up, man.
Yeah.
What he's trying to tell you there is you can't have 2 things happening at the same time. Basically.
Actually, you can, once again, because you're explaining from 2 different reference frames.
It doesn't matter how many reference frames. Reference frames won't save you here because you have a fabric in one bending, and then on the other one, you have 2 things attracting each other. Those are 2 different things.
Yes, they are. However, they explain the same phenomena. And in 3 dimensions, we've experienced the phenomena as Newton.
No, no, you can't have it both ways. You can't have it be both a
yes, I
force
can.
and not a force. You can't
Yes, I
have
can.
it. Sorry.
Yes, actually, yes, I can, because these are two different things. One explains how, and the other explains why.
So you have a not force in one of them. Gotcha.
No, you have if you want to think of it as not force, that's fine. Think of it as, we'll call it what, the SE. What do you want to call it? The Yogi force or what?
No, it's the Zanickian not force. We already named it. Sorry.
Oh, I don't know why you named after Zanick, but okay, I prefer to call it a. But I mean, we perceive it as a force.
But it's not a force.
It is force. We perceive it as one in our environment. It's holding your
You can
FedEx.
perceive it all you want.
We measure it as a force all day long, 9.81 meters per second per second.
That's the Newtonian one you measure here,
It's also
right? The one with the
Einsteinian.
force.
No, you don't measure it as a force.
Yes, we do.
You
9.81
don't.
meters
You
per
don't
second.
measure it as a force. Zanick spent all morning telling us how. Am I breaking up still?
No, he's just interrupting.
We do measure it as a force.
Yeah,
9.81
Zanick
meters per second.
spent all morning.
Man, why can't you just shut the fuck up sometimes, though, guy?
Keep it
Go
up, you're
ahead.
gonna get muted. That's as simple as that. You don't let him talk, you're gonna get muted. We're not gonna get mad or waste our time with you. You've been warned, bro.
He's already muted. Go ahead, Jeremy.
Jeremy, maybe he reset his phone or
Well,
something like that.
why'd you mute him? He wasn't really interrupting anybody. You guys were back and forth.
No, he absolutely was interrupting Jeremy multiple times.
It's like, why can't you have a normal freaking conversation, man? Why?
Oh, in order to have a normal conversation, I need like normal people to come back. And all Jeremy is saying and all you're saying is the same old thing. It's basically that's all you're saying.
So let us say it and then rebut. You think you can
Why
do
don't
that?
you ask NASA what he would or would not disagree with me on? Was the forces?
You just asked him.
He said, "Are the forces real? Are they actual?" Well, don't you ask him?
Oh yeah, he was talking about a force, just like you. That's not a force.
A
And
pseudo
then he's
force,
bringing it
fictitious
on
force.
Earth and saying that he measured it. But
Yep.
you're saying, but you yourself, Zanick, said there's no force there.
You can measure
So
inertial forces.
Which is it?
An inertial force is reference frame dependent. It's still measurable. Just means it doesn't have a source. It means it's reference frame dependent.
So you're measuring a force without a source on Earth, which needs a force. Do I get that? Am I getting this
Now
correct?
you're kind of double. You're talking in circles there. We can measure centrifugal force. If you want to put a scale on a centrifuge, like one of those rides, and the actual wall itself is a scale also, they both will give readings, and lo and behold, they'll have an equal value. One's measuring the pseudo force, one's inertial force, and one's measuring a proper force or real force, as Gleam is all on a mission to prove me wrong about. My God, it's so funny.
Don't say pseudo force to flatties. Say emergent force.
The pretendo force.
I know.
No, we have a new term now, the not force.
I know.
I call it. I'll just call it inertial. Can I call it inertial force? How about inertial force?
But don't say pseudo force, because these guys hear pseudo.
Zanick. Yeah, real quick. Okay, real quick, Zanick. You told us this morning things were falling 9.8 meters a second squared, accelerating, and you can't measure a force on that.
Correct. They're in free fall.
So you can't measure the force, but you're saying there's a force there. But you're saying there's no force there. You can't measure a force. Newton said you need a force.
Now, when they're free falling, there's no force acting on them.
Okay, where they're accelerating, the thing we're arguing about, this acceleration. You guys are saying in one instance there's no force.
Well, the Coriolis deviation shows a curved path. There's a Coriolis force because that's what would be required.
We're not talking about Coriolis, dude.
Hold on.
We're not talking about Coriolis.
It's what takes it, what acts on it in terms of forces to make it take the curved path with respect to the non-inertial reference frame. But in actuality, there's no forces acting on it. Same thing. They're both analogous.
I know what he was saying, and you guys misquoted him, of course, SE. What he's saying is that if you drop something and try to weigh it as it's falling, it has no force. That's totally true. It has no weight as it falls.
Yeah, there's no force there. Newton said you need a force there.
Well, it's still
something's accelerating. F equals ma. Remember?
And you can measure that from the outside reference frame.
We say that object that is free falling from the non-inertial frame would require force to accelerate it, and it would give newtons to force in terms of newtons to that object, regardless with respect to its mass. But it's not a real force; it's a Lambert force, is inertial force. I've been instructed by my NASA Shill team to not mention pseudo force.
Just don't say. I know pseudo force is scientifically correct, but these guys hear pseudo and think fake.
I know. Just trying to make it as easy to understand as possible.
Professor Parks likes
force or it's not a
emerging.
force. Hold on, SC. It's either a force or it's not a force, guys. It's either apple or it's non-apple. Can't be pseudo pregnant. Okay.
Well, that's not entirely correct.
Oh, so you can be kind of pregnant?
Oh, there are pseudo pregnancies though.
No.
False pregnancies.
Yeah, there's false pregnancies.
And so my wife is pseudo pregnant right now.
Men can get pregnant too.
I don't know. No, we won't go into that.
You guys listen to this. Okay, so
think of the object in the car.
Defending the globe think that men can naturally get pregnant.
I won't talk to you about your wife because I'm being nice.
How does the car stop?
You better be nice about that because then I'd have to physically find you. Ooh, and that wouldn't be good for you.
How does the?
You'll keep your mouth shut. What are you saying, Zanick?
How does the object in the car, the balloon, for example?
What are you talking about?
How does that balloon end up hitting the windshield when the car stops
without a real force? I don't want you to take me off in a hypothetical land because I don't get lost there with you. Others do. I don't.
What do you mean?
You seem to be getting
in
lost.
Hypothetical land. 3/4 of the shit you post is hypothetical.
So then it's not a force, right? It's a pseudo force.
Emergent force.
Okay, it's not a force. It's an emergent force.
Well, it is a force. It's an emergent force.
Oh, so gravity is a force?
Yeah, emergent force. Yes.
Oh, so it's not a force.
It's emergent force.
So it's not a force. It's in something called an emergent force.
It's a real force in a reference frame. No, don't think that emergent force.
So is my urination later going to be real urination, or right now is it emergent urination?
Let's go to potty land now.
Well, dude, you take it there. We're not taking this seriously. We know you're not being honest.
Right,
you defend the globe.
I got you. Let's go right.
We know you're not being honest because you defend the globe.
2-year-old. Let's go to potty land and talk about potty.
I'm saying you want me to treat you like an adult. Stop lying to us.
We're not. These are totally.
That's all. That's all you got to do.
True. If you had a background in physics, which.
So gravity is a force or not? No force? Yes, force. Yes. Oh, weird, because earlier your cohort said gravity is not a force, and we have the recording.
Well, you see, it depends.
I'm done. You guys you're great. Thank you. Thank you.
What are you talking? You're talking Einsteinian? Well, gravity isn't a force in Einsteinian. It's felt as a force, but it's not a proper force. It's an emergent force.
So the Zanickian not force, that's the one I like. The new force that we came up with today.
I think I like Yogi force better.
The Zanickian not force, that's beautiful.
Yogi Bear not force.
No, I like what SC's got. That's good.
So once again, you have nothing, Shill. You just came in here to waste our time as usual.
No, I've got everything, and but you haven't. Once again, you just show that you can say no a lot.
You said nothing so far. Nothing.
Yeah, I said nothing. I thought gravity is an emergent force.
Which is nothing. What is it emerging from?
from the reference frame, the same way that centripetal force is an emergent force.
So the force that you're claiming, it's coming from a reference frame.
In the same way that a centripetal force is from a rotating reference frame.
Centrifugal force. Centrifugal.
So now it's a spinning force.
Well,
This not force.
That's
It's not a force. Now it's a spinning force.
That was called an analogy. Something trying to get to something that you might have a little bit more knowledge about, but obviously not. You missed the analogy, but okay.
No, the analogy and the spinning we understand. Something is spinning, creating something. We get that. But where is this emergent not force coming from?
From the bending and warping of space-time due to mass.
From the bending and so not from matter attracting matter. Not that force. Not an actual force.
Matter attracting matter works in non-inertial systems.
Bending is
relativistic forces.
So in the bending of the fabric of Warstein, you're talking about falling now. Is that what you're talking about?
What's that?
In the fabric of space-time, which you say is not a force, what are you describing there exactly? What's happening there?
Mass bend space-time. So
you're falling into like a sorry?
You're falling into like a space-time well, if you will.
Like a trampoline.
That's sort of that's used in 2 dimensions, extending to 3. And you have a hard enough time thinking in 2 dimensions or 3. We won't go to 4.
So now we're up to 4 dimensions because we have a hard time understanding 3. But let's go to 4.
No, you have a hard time understanding 2, but
so we'll go to 4 then. That'll make it more easier to understand. You think your games are going to work here, bro? They're not going to work here, your games.
No, for you they won't work. I understand.
Yeah, you got that right.
Yeah, because you lack the gray matter to understand it.
Well, you're the genius. You said we can't understand 2 dimensions, and then you brought us to 4 dimensions. So go on, extrapolate from that. How does that work?
No, I don't need to go to 4, but beyond 4.
Not beyond the 4 that you mentioned. Can you care to extrapolate on that? Like, tell us, what do you mean exactly?
You mean elaborate, not extrapolate.
Elaborate. Thank you. My bad.
No, because like I said, you barely understand 2 dimensions when you brought up the fabric of space-time, which is again an analogy.
Well, yeah, we're the dumb ones. You're the smart one. You came here to teach us, so go on.
No, I actually did.
Elaborate, like Zanick said. Elaborate on your 4 dimensions.
I'm not here
please.
to teach you much, SE. That I've learned that is an impossible task.
So my point exactly. You just came here to waste our time.
You should go back to 5th grade and write a check to the Canadian government for wasting money on you trying to teach you stuff.
You see? I mean, come on, man. I mean, aren't you fed up of doing this? Seriously.
No, actually, no. It kind of cracks me up that you're still this thick.
You come here to like try to make yourself feel better or something.
Was that Witsit?
I think you just come here to like try to make yourself feel better about yourself.
Witsit, how are you? It's been 2 weeks I've been listening to you. How are you doing?
Bro.
Let's see if you can form a coherent sentence. Let's see.
Can you apply physical properties to conceptual abstractions?
Well, can you?
No.
Oh, I didn't think so. Okay.
Wouldn't that be misplaced concreteness to an abstraction, also known as a reification fallacy?
No, you don't understand reification at all.
It's like a cartoon character or something.
Yeah, it actually sounded exactly like a reification fallacy, like textbook.
See, he can't form a sentence. He can't form from the time he came here, he didn't say one coherent thing, not one. All ad homs and
I understand.
yeah.
To you, that's probably true. I agree with you.
Dude
To you,
doubles down with an ad hom.
That's not ad hom. It's
Yeah,
just explaining. I haven't ad hommed SE once. You need to learn what an ad hom is. What's it? You never did have learned that either.
Yeah, your argument right now is just to say SE's dumb, basically.
That's not an ad hom. That's a description of his
No, it's your
intelligence.
argument right now, so.
No, that's not actually. Okay.
Boring.
I know it is. What's it? Facts are boring to you.
So make an argument. Come on, give us your best argument. You have all the dumb people here.
But I just want
Give
to
us.
like, what if I just keep hitting him with questions I know he can't answer though?
That'd be good too.
So, how if matter contracts as it increases speed closer and closer to relativistic speeds, and then continues to contract? How could it reach the relativistic speed and then mass expand exponentially?
It's not that it's
Good try, buddy. Well, what you got here, Shill?
Why? How come you always go to relativity when you don't understand basic physics? It's like, hey, let's go talk about stuff that's really difficult, and I can
Another
answer
not
that.
answer.
Yet you won't explain. Yet you don't understand simple physics.
See if you
This
can.
cracks me up.
This is the definition of an ad hom, right? Like in your
No, this isn't
argument.
ad hom. This isn't ad hom. Ask a simple question.
Your response back is to obfuscate to personal insults as your
No, I
argument.
didn't personal insult again. I ask why you always go to.
So you don't
relativity.
know the answer?
Do I know the answer? Is it important? Why are we talking about relativity? We weren't even anywhere near relativity.
Let's see if you can answer this. Can something contract to nothing and expand infinitely at the same time?
What are you talking about?
You can't even answer that.
You don't know what you're talking about.
Does
Oh yes, he does.
Does the length contraction get greater the faster you go?
Or does matter expand exponentially?
Matter doesn't expand.
Are you sure?
Ooh, you're a relativity denier.
The word of expand is incorrect, but that's okay.
Well, okay, then explain it.
Oh, to you, no.
You don't know.
To you, I'm not good. I mean, come on, Witsit. You don't. How can you understand? How do you expect to understand relativity when you haven't studied basic physics?
Well, you definitely don't understand relativity, right?
Well, probably understand relativity much more than you do, but
Then why can't you answer the question?
Because it's a dumb question, and you're just trying to, to show everyone, ooh, I can ask a question that's difficult to understand, and then when I answer it, you're going to laugh at me because you don't understand. You don't have the physics to.
Oh, you're boring. You gotta do better than
No, I
this.
am boring. Yeah, I know I'm boring.
Does the length contraction effect increase as you increase speed?
In which time frame? In which reference frame?
The one that's inertial.
Well, you can't go to infinite speed, so we'll never find out.
Well, wait, you can't what?
You can't go to infinite speed, so we'll never find out.
Why would you? It doesn't say you have to go to infinite speed, though. It says all objects in motion contract, and then they contract more and more as they approach relativistic speeds.
Okay, and you have a problem with that because why?
So you agree that the length contraction effect does increase as you approach relativistic speeds?
Okay, so
do you agree?
You? Well, you're trying to get me to say something wrong. What's it? I'm not playing your game. Sorry.
Wait, so you disagree?
I'm not playing your game. What's it? Sorry. I'm not playing the Witsit.
No, you're gonna say two right things without noticing it, but yeah.
I'm not gonna say.
He's so scared because he doesn't know if I'm like setting
He
him
knows
up.
it. He knows. He knows.
I'm not playing the Witsit game. Sorry.
He
Witsit
doesn't know if I'm like asking him a question that he should say yes or no to, so he's like just avoiding it.
I'm not playing the Witsit trivia game today. Sorry.
Oh. So okay, it's okay. If you don't understand your belief, but you blindly hold that belief.
See, Witsit, have you been to China?
Totally relevant.
Yeah, it's totally relevant. See, you think you can only you mean you're working this computer or phone. Do you understand how it's made and how semiconductors work and all that?
I mean, I have a decent idea, but The point is that like you can go replicate it. I mean, it's a physical, actual thing that can be verified. The computer's sitting here working, so I don't really see how that's relevant to something. Buddy, calm down. I get that you're a relativity denier. It's
You can
okay.
verify relativity. You can verify time dilation.
Yeah.
It's been done.
So, so you said nothing can go relativistic speeds?
You can verify time dilation.
All right, dude. I'm disengaging.
Of course.
You got nothing. You can't answer basic questions.
I just told you can verify time dilations. And
Not one. He didn't answer one question all night. Not one.
I can't even get to the like the better ones because you just can't even answer the basic ones.
I told you can demonstrate time dilation, and you're going to run away. Gotcha.
Does the Earth change direction in its orbit around the sun?
It goes in a circle, so okay.
So does it change direction?
It rotates in a circle, so okay.
Okay. So in a geodesic path, is the object changing direction?
In a geodesic path.
If that makes you feel better.
What do you mean? It rotates in basically a circle around the sun, so okay. What's your problem?
In order for an object to change direction, does it have to have a force acting upon
It's
it?
called gravity. Yes, we know about that. Thank you.
Oh. So gravity is a force.
In Newtonian, yes.
Oh, so you are a relativity denier.
Well, okay, if you want to think of it this way, the sun has a very big bending of space-time, and we're going on the geodesic around it. Do you want to work out in that direction? They both work.
Well, if it's a geodesic, then we're not changing direction.
Well, we're going in the lowest energy path around the sun, which is, in our 3D time frame, in our 3D representation, it looks like a circular orbit.
Are you a relativity denier?
No, it's it. The problem is that they can be explained both ways, and that's your problem.
You know they're different things, right?
But they describe the same thing.
Well, they're fundamentally different, though.
But they describe the same thing.
You realize that relativity superseded Newtonian mechanics.
Not supersede, explained.
No, it's a fundamentally different theory. It claims it makes opposite claims.
No, actually, the tensors will, if you will, collapse to Newtonian physics and non-accelerating, non-inertial time.
But the theories of physics make opposite claims.
Actually, no. One explains how, and one explains why.
Do you want me to teach you?
Oh, you teach me? No, you can't teach me shit.
I got you. All right. So in Newtonian mechanics, if I drop an object, then it accelerates in a straight path down unless a force acts upon it. Okay. In Einsteinian physics, when I drop the pin, it's actually not accelerating down. It's not going in a straight path. It can just look like a straight path. And objects can change direction without a force acting upon it because of the geodesic path.
Which we would describe as a force in three-dimensional space. Yes.
No, relativity specifically says that gravity is not a force.
Relativity is a four-dimensional curved space-time reference frame.
Right. It's not a force. It's a coordinate system that guides objects.
We live in a three-dimensional reference frame, which requires this, which we experience.
All right, dude, you're boring. All right, I'm gonna have to unmute Zanick. Unfortunately, sorry to the room. Unless someone else wants to like deal with this guy.
I'm
this guy
boring
can't.
because I can explain to you that you're wrong.
It's a waste of time.
No, you can't even answer the basic. You don't even You're a relativity denier.
I'm not a relativity denier. The relativity
You are.
No. The problem is you think that relativity superseded Newtonian, and it didn't.
They're fundamentally different.
They're fundamentally the same thing, trying to explain the same forces, doing it slightly differently. Yes.
Wait, so is the math the same?
Math is if you take Einsteinian tensors and use non-accelerating, non-inertial reference frames, then they will collapse back to Newtonian.
So, what are they the same or are they different?
Well, they go from different theories, but guess what? They explain the same movements.
This dude said non-accelerating, non-inertial. So, if they're the same, then why do they have different mathematical predictions for the orbit of Mercury?
Because once again,
You're laughing nervously, Matthew.
oh no,
No,
because
I'm
how,
just
how much
amazed.
how much
Matthew, do you
how
know
much
the answer?
variation
If
how
they're
much
the
var-
same, why do they have
how
different
much
predictions?
variation was there in Mercury? Do you remember?
It's like some 40 arc seconds or something.
40 arc seconds per what time frame?
Century.
Yeah, not a lot.
That's
No.
called a non sequitur.
No, that's totally because again, if you're not in a accelerating, if you're not moving fast to fastest speed light, you're not very small, and you're not near a large gravitational mass. You can use Newtonian physics. We use Newtonian physics all over.
Now you're just using
Just
red
said
herrings.
sequitur. See, he said non sequitur. You said no. You should have said it's totally sequitur.
Yeah, but he just like proceeded to expand on the non sequitur.
In the meantime, we use Newtonian physics all the time to explain baseballs, satellites.
Red herring fallacy.
No, totally correct.
Do you know what a red herring fallacy is?
We don't need to use Newtonian. We don't need to use Einsteinian physics unless we are in a very small section of where we need to go.
Do you know what a red herring fallacy is?
It's not a red herring fallacy. It's a red herring fallacy would mean that it's not true.
That's not what that means. No, red herring fallacy means it's a distraction to obfuscate and divert away from the actual
Not
point.
a distraction. I'm saying we use Newtonian physics all the time.
Was that relevant to what I said?
Yes, totally.
What did I say?
You're saying that they're opposite, and we don't. You say that Einsteinian physics superseded Newtonian physics.
Buddy, check this out. Are you aware that Newtonian mechanics said there was a fixed background of space?
What's that?
Newtonian mechanics said there was a fixed background of space. Okay, did you know that Einsteinian physics specifically says there is not a fixed background of space?
Yeah, they have different assumptions and they come to this.
So are those opposite?
They have different assumptions and they come. Guess what? But the equations, the math works in both of them.
The math is different, dude.
The math is different. Yeah, but guess what? It comes down to the same thing. All of Einsteinian's fancy tensor equations will collapse to Newton's equations.
We just talked about how the math's not the same. They have different mathematical predictions. So
when you're in very strong gravitational fields, like 40 arc seconds per century for Mercury.
Okay, so that's just on the small solar system scale, but they're different, and they're fundamentally different in terms of physics. You understand that math is not reality, right? So I could show you Newtonian's. Look, I could show you. Stop interrupting me, dude. I could show you Newtonian mathematics, and I could give you 100 different interpretations of it and claims about physics. There's no way that all 100 of them are correct, but I could say, look, the math matches in all of them. That doesn't mean that the theory of physics behind the math is correct.
Yet we use Newtonian physics every day of the week to do lots of different stuff, and it works quite well. Thank you very much.
I just explained that the math isn't reality. It's about the theory of physics behind it, and your response was, the math works?
Yep, the math works. Do you understand the power of that statement?
Do you understand? Do you understand that physics is not? Physics is not about math, right?
It is actually. Did you understand that? Newton invented calculus to explain his observations.
Yeah, you think that Newton introduced a dynamic force and invented calculus before 23. But what I want you to address is that math is not reality, and physics tries to explain the way the world works, and then we apply math to the theory to describe it.
Yes, math is a language of physics. That's correct.
Okay, so the math describes the theory of physics that proposes an explanation for how the world works.
Math is the language of physics, and you are math impaired. That's understand that.
So where is the proposed explanation of how the world works accurate or not?
Yes, it's quite accurate. We use Newtonian physics all the time.
Newtonian physics doesn't work in your own paradigm.
What do you mean it doesn't work? We use it all the time.
Okay.
We use it to throw baseballs. We use it to launch missiles. We use it to fire cannons.
I can use a kinematic equation for all of those things that doesn't even account for mass. That's irrelevant.
No, you can't. You have to.
You can't do statics without it.
Do
You have to go from
statics?
Right.
What do you mean?
The branch of physics called statics is Newtonian, and that's what you use to build buildings and bridges.
Why can you not use a kinematic equation?
I'm saying you use Newtonian physics to build buildings, and you don't need relativity.
Yeah, but can you use a kinematic equation?
You can use a kinematic equation for building buildings and bridges. Yes.
Yeah. Okay. So then